Hello everyone, my name is Professor Wilson Kamami. My YouTube channel is also called Professor Wilson Kamami. This is where we simplify mathematics together. This is our sixth topic on subtopic on statistics, especially when we are looking at group data. So today we are going to look at how we calculate quartiles. And from there we shall look at how we get interquartile range, semi-quartile or quartile deviation, such things when we are going ahead with this. So we are going to take an example. Let's take an example on how we calculate the quartiles and quartile deviation. But before then, maybe I can explain something little. In our previous video, we looked at how we calculate median, how we calculate decile, and how we calculate percentile. So with this one, we assume we are having something like this. If you divide it into two, there at the middle, that's where we get median. We are assuming this is our first, that is the five. So if you cut it again, the first part you get is a quarter. So maybe it's a quarter bread. So if you get 3/4, if you cut at this point again, you divide this into two, you are going to get 3/4. So this first quarter, we call it lower quartile. And this one, 3/4, we call it upper quartile. So I want you to understand that in this case, we are dealing with the quarters. The other videos we divided, we just calculated median, and then we focused on how we get deciles. Decile was in terms of over 10, percentile was in terms of 100. So in this case, we are dealing with the quarter. So we have the first quarter, we call it lower quartile. When you have a half, we call it median, which we calculated on our previous video. And then when you have 3/4, we have what we call upper quartile. So as I explained from my previous video is that the formula for all this will remain the same. We only change a small part of it. For median, lower quartile, upper quartile, decile, percentile, the formula is the same. As we agreed, for like in this case, maybe we can say for lower quartile, Q1, lower quartile, we use this table Q1, and upper quartile Q3. So if you ask the formula for lower quartile, it is L plus, I said this is the only part that changes. This will be now quarter N minus CF. We said cumulative frequency before all over frequency I. For upper quartile, so it will be L plus, now because it is 3/4, so the formula here will be 3/4 minus CFB all over F I. So as you can see, even the median, if we have to write the median, remember median we are using half to show that it is half. For percentile, if it is 60th percentile, we are using 60 over 100. For the decile, we are using 4 over 10. And so that is the only part that was changing. And as I explained from my previous video is that this is the same part that will guide us on which class we are going to use. Let's take an example. We are going to take the same example. We have a mass in kg. Maybe you have 50 students. You want to know how they weigh. So 40, those who weigh between 40 and 49 kg, you find there are 6. That's what we call frequency. Those who are between 50 and 59, you find there are 9. Those who are between 60 and 69, you find there are 12. 70 to 79, 14. 80 to 89, 5. And 90 to 99, there are 3. So in a total class of 50 students, that's the distribution of their weight. So the total frequency, the number of students were 50. So we now, as I said, when you ask median, whatever, we only introduce one column. We call it cumulative frequency. I explained further about this one from my previous video, my video number 5 on this one. So in this case, my cumulative frequency, the frequency of the first one is 6. So you keep on adding 6. You add the next frequency of 9 to be 15. You add now 12 to be 27. You take now that one, you add 14 to be 41. And you take this one was 6, sorry. That one was 6. So 41, you add 6, you get 47. And 47, when you add 3, you are going to get 50. So you only need to introduce the cumulative frequency. So when we come to lower quartile now, and from my previous video, I also explained how we get the class boundary. I said for this one, you look at how we are changing. I explained into details how we are changing from 49 to 50. It is 1. So you divide into 2. That one is 50 minus 49. You divide by 2, you get it is 0. You get the difference is 1. When you divide by 2, it is 0.5. So what you'll be doing here, you'll be subtracting. Here you'll be adding. So here you'll be subtracting that 0.5. I explained again on my video number 5 on how we get that one. So here will be 39.5 to 49.5. Here you subtract 0.5 to be 49.5 to 59.5. Here you get 59.5 to 69.5. Here when you subtract it to be 69.5. Here when you add it to be 79.5. That way. So you get 79.5 to 89.5. 89.5 to 99.5. So now, how do we get the lower quartile? We said with lower quartile, Q1, what we are going to do with lower quartile, Q1, we said it is a quarter n. So, quarter of n. So, it will be a quarter of my frequency, which is 50, and you are going to get 12.5. We said when you get this 12.5, you go to cumulative frequency column. So you look at where are you getting 12.5. We said this is 0 to 6. Then when you add 7 all the way to 15, this, so 12.5, you are going to get it at this class. That is the class that we are going to get our lower quartile. That class. I can call it here Q1. So when you get that one, we have already gotten our Q1, the class that we are going to use. So my Q1 will be equals, what is the lower class limit? The lower class limit is 49.5. So it will be 49.5 plus, we said here it is quarter n, we got it is 12.5, minus cumulative frequency before, not this one, before. That's the only part that we don't use of this class. It is of before, which will be 6 minus all over. Now, what is the frequency of this class? 9. And what is the interval? The interval is the difference between lower and upper limit. So here you get it is 10. 59.5 minus 49.5, you get is 10. So in this case, we are going to get is 49.5 plus 6.5 all over 9 times 10. So we are going to get 49.5 plus, this is like 65. 65 divide 9. What are we going to get? 7.22. And when you solve that one, we are going to get, it is 56.722. You are going to get is 56.722 because this was 7.222 recurring. So in that case, that's how we get to the lower quartile. How do we get upper quartile? How do we get upper quartile? Q3. So Q3, we said it is 3 quarter. So first of all, we have to get that 3 quarter n. So it is 3 over 4 times 50. We are going to get it is 37.5. When we get it is 37.5, we say we go to cumulative frequency column. So this is guiding you which class are you going to use, and in this case you are going to realize that we find it in 41 because it cannot be in 27. We are going to find that 7.5 in 41. So this is where we are going to use Q3. The other one we used was that one. So my formula again, Q3 will be equals to L. What is the lower class limit of this Q3? 69.5 plus 3/4 N we have already gotten is that 7.5 minus cumulative frequency before, which will be 27, all over, what is the frequency in this class? 14, times the interval. Interval I said is the difference between lower and upper. You get it is 10. So when you solve this one, we are going to get it is 69.5 plus, when you get the difference between this one, you are going to get it is 10.5 all over 14 times 10. So when you solve this one, 10.5 over 14 times 10, it is like 105 divide 14, you are going to get 7.5. So this will be 69.5 plus 7.5. And in this case, we are going to get it is 77. So that's how we get the upper quartile. It will be 77. So, as I have explained, it is easier to get the lower quartile and upper quartile, median, percentile, decile. We say the only part that changes is this one, and this part is the same part that will guide you on which class we are going to use. So that's how we get the lower and upper quartile. So when we proceed from there is that we are going to get, we have gotten our lower quartile, our upper quartile. So someone may ask you now, how do we get interquartile range? Interquartile range. Interquartile range is the difference between upper quartile and lower quartile. So the difference is Q3 minus Q1. And in this case, it is 77 minus what was our lower quartile? 56.722. You are going to get that one. So when someone asks you interquartile range, we also have interquartile, we have what we call quartile deviation. Quartile deviation, it will be Q3 minus Q1 all over 2. So in this case, it will be 77 minus 56.722 all over 2. So this is how we get this one. When you get upper quartile, lower quartile, you can be asked a lot of things. This quartile division, sometimes you may find is the same. We call it semi-interquartile range. Semi-interquartile range. So when you subtract this one and this one, we are going to get 20.278. 20.278. So again, when you get 20.278, it is the same that 20.278 that we are going to divide by 2. And when you divide by 2, you are going to get what we call 10.19139. That's how we are going to get the quartile division. And the last thing is that you can be asked to calculate the coefficient of quartile division. How do we get the coefficient of quartile division? It will be Q3 minus Q1 all over Q3 plus Q1. So that one you can go and calculate how we get the coefficient of quartile division, which will be Q3 minus Q1 all over Q3 plus Q1, and you are going to get 0.516 something. 1516. 0.1516. So that's how we get the quartile division. And from when you have already gotten lower quartile and upper quartile, it is easy. Now you can be asked any question. Find the interquartile range. You only need to know it is the difference between lower and upper. Quartile division is that difference you divide by 2. Coefficient of quartile division, Q3 upper quartile minus lower over upper plus lower quartile. Thank you for that one. Keep on subscribing, keep on sharing so that we can continue to simplify mathematics together. Thank you.